Morning guys, so we're going to do a recap video of area. What I'm going to do is I'm going to go through 3 questions. These are on the top of your sheet so that you can write them down as examples, and then you've got a set to have a go at underneath, and we're going to do the 3 different topics that we've done on area, so that you can have a go at them and hopefully make a little bit more sense of it. So whenever you've got these sorts of shapes, all you want to do is split them into nice easy shapes to work out. So if you want formulas, if we've got a rectangle, base and height, the area is just base multiplied by height. If you've got a triangle, now that could be drawn either way around. You've got base, in this case, because it creates the right angle, that height there is actually the height. In this one, the height is always given with an arrow. The arrow could be drawn outside or inside the triangle. As long as it's a vertical line, it's the actual height. And for the area of a triangle, it's base times height and half it. Okay, at this point, those are the only 2 formulas you're going to be needing for this. Okay, so on this one, what I can do is if I split it there, I've got 2 nice simple rectangles. Now, this rectangle here is still 9 centimeters wide because I haven't changed this width, and it's still 12 centimeters high because I haven't cut that width length at all. So for that one, it's literally 9 times 12, you get 108. This rectangle here, you have to think about a little bit more. The height is still 3 because I haven't changed that height in any way, but the width is only up to the line that we've drawn. So if all the way across is 17, but I know that that width there is obviously going to be the same at the top as it is at the bottom. So if that width's 9, so is that one, which means this width here of the rectangle I'm actually looking at is 17 subtract 9. That leaves me with 8. So this rectangle here is 8 times 3, which equals 24. So to get the total area, you're going to do 108 add 24. You get 132 centimeters squared. Hopefully that one is now nice and straightforward. So same idea on the next one. What we're going to do is split it. Now you can split it straight across, you can split it straight down. I'm going to split it straight down. That means what I've got here is a width of 8 and a height of 19. So I haven't changed either of those 2 measurements. So this rectangle here is 8 times 19, which you can just chuck straight into a calculator. So 8 times 19 is going to give us 152. Now this one here, it has a height of 7, so I haven't changed that height in any way. But the width here only goes up to the line that I've drawn, and the width that they've given us is all the way across. So if I know all the way across there is 10, I know this bigger chunk has a width at the top of 8, so the width at the bottom would also be 8. So that means this part here is just 10 subtract 8, it leaves me with 2 centimeters wide. So the area of this rectangle is 7 times 2, which is 14. So you're going to do 152, add 14, you get 166 centimeters squared. Okay, again, hopefully that makes a little bit more sense now. And then if we look at the last one, what you've got here is if I split this shape at that point there, what I've got is a rectangle and a triangle. Now the rectangle is nice and easy. The width of the rectangle is 5, the height of the rectangle is 8. So it's just 5 times 8 equals 40. Now this is where we have to be careful. To get the height of just the triangle, I only need that part there. I know that length there is 5 because it's the same there as it is at the top, which means if I do 16 subtract that 5, I'm left with a height of my triangle as 11. The base of my triangle is the same there as it is there, so the base of my triangle is 8. So for the triangle, we're going to do 8 times 11 and half it, because remember our formula for a triangle is to half it afterwards. So I get 88, half of 88 is 44, and then all we do is add together our 2 measurements and you get 84 centimeters squared. So what I want you to do is at this point, just make sure that you've got those examples and they're nice and clear. Listen through again if you need to, and then I want you to move on to this section. Now it's up to you. If you haven't been able to print the sheet, if you just want to pause the screen at that point, give the questions a go. Any problems, let me know, but just make sure you pause it, have a go at the questions, okay? And then we're going to move on to the next one. When you're done, can you take a picture of the workings that you've done for this and send them in? Can we just label them, because I forgot to put numbers on, if we just go across each row? So 1, 2, 3, 4, 5, 6. Okay, so you've got 9 questions to have a go at. Any problems, any you're not sure about, feel free to just do a quick sketch of the diagram, write down your workings, send it in, and I'll check it for you if you want to just be sure that you're doing the right thing. Okay, once you've done that, we're going to move on to the second section. So this is looking at trapeziums and parallelograms. Now, a parallelogram just kind of looks like a square or a rectangle that's been pushed over. Okay, in a parallelogram, you've got base, and just like with a non-right angled triangle, the height has to be a vertical height, so where it makes a right angle with the base. The diagonal side you actually do not need. Okay, area of a parallelogram is literally base times height, just like it is with a rectangle or a square. Okay, and so we'll do those 2 examples first, and then I'll talk through the next one. So in each of these cases, what I've done is I've given you all 3 measurements. One of those measurements will not be needed. So remember what I said, you only need the base and the height that makes a right angle, which means the diagonal side is not needed. So it's there to almost see if it can trip you up. Okay, so the area of this is base is 15, height is 4. You're going to do 15 times 4 is 60 centimeters squared, and that's it. First one done. So if we look at the next one, again, one piece of information isn't needed. So I've got my vertical height because it's making a right angle with a base. I've got the width of the base, which is the same there and there, and so the diagonal side is not needed. So with this one, it's just 8 times 12 equals 96 centimeters squared, and that's it. Parallelograms are done. Okay, they're just like rectangles, base times height. These ones are a slight bit trickier just because the formula's a bit more detailed. On a trapezium, the actual formula, if I draw you a small trapezium so you can write your formulas down, the 2 parallel sides, so they're the 2 sides that will never meet, you label those 2 sides as A and B. Doesn't actually matter which way around. The height is the distance between those 2 sides, and we call it H. Okay, and the formula is to add together the 2 parallel sides. Just make sure if you're typing this straight into a calculator, you include the brackets, times by the height, and half it. So in this one, these 2 sides here are my parallel sides, which means they are A and B. And like I said, it doesn't matter which one you label as A and which one as B. The height is the distance between them. So this is a trapezium that's been lay on its side, but we still class the distance between them as the height. So we do 8 add 22, times it by 5, and half it. Now, if you've not got a Casio calculator, what you're going to do is just ignore the divide by 2 part to begin with. I want you to work out that bit. You can type it in exactly as it says there. Click equals on your calculator and then click divide by 2. Okay, if you have got a Casio calculator, what you can do is just type it in exactly as it's written there. So you click the fraction button first. On the top of our fraction, open your bracket, 8 plus 22, close your bracket, times 5, and then press the arrow down to go to the bottom of the fraction, divide by 2, you get an answer of 75. So my answer is 75 centimeters squared. Okay, we do the same on the next one. Top and bottom this time are our parallel sides, so these are A and B. Distance between them we call H, so I've got to do 5 add 13, times it by 7 and half it, and again you can type it in the calculator exactly as it's written there. So for those with a fraction button first, you do 5 add 13, times it by 7, and then on the bottom divide by 2, you get it helps if I wrote add instead of minus, sorry about that. You get 63, so I've got 63 centimeters squared. Just to show you, if you don't have a Casio calculator, it still works exactly the same, but what you're going to do is, as I said, pretend the over 2 part's not there. So 5 add 13 times by 7. Okay, that's going to give you 126. And then without clicking anything else on my calculator, I'm not going to clear the screen. I'm just going to click divide by 2. And you'll notice it will come up with answer, divide by 2. That's because it's using the last number that was in your calculator. Divide it by 2, you still get the same answer of 63. Okay, that then means what I want you to do is make sure that you've got those examples written down, listen through it again if you need to, and then you've now got 8 questions at the bottom to have a go at. And again, can we just label them as you go across each row? So 1, 2, 3, 4, sorry I forgot to put the numbers on, 5, 6, 7 and 8. Okay, so again, pause the video at this point, try as many of these as you can. Any problems, feel free to take a picture, send it in to me, and I will get back to you as soon as I can. Okay, and then once you've done that, we're going to move on to our third topic if there's enough time, which is circles. Now, a few things that we need to know about circles. You've got, first of all, if you've got a line that goes from the centre to the outside, now it can be at any angle, it can go straight across, straight down, other direction, at an angle. As long as it goes from the centre to the outside, it is called the radius. Okay, whereas if you've got a circle that goes all the way, sorry, a line that goes all the way across your circle, passing through the centre, we call it a diameter. Okay, so obviously the radius is half of the diameter, because the radius goes halfway across a circle, diameter goes all the way across a circle. Okay, reason for that is on these ones where you're given the diameter, you're going to have to half your numbers first before you put them into the formula, because the formula for area is pi times the radius squared. Now don't panic at seeing pi. Pi is literally a button on your calculator. Okay, it's actually the relationship between the diameter of a circle and its circumference, but at this point we don't need to worry about that. All you need to remember is pi times radius squared, or shorthand pi r squared. Okay, so on this one, as you can see, I've got centre to the outside, so that's a radius. So my radius is 8. So to get the area, I'm going to do pi times 8 squared. And you are going to type it into the calculator exactly as it says there. So I'm literally going to type in shift, and then at the bottom where you've got your times 10 to the power of something button, you can see written just in yellow is a pi symbol. So if you click shift first and then that button, you don't have to hold shift, just click it. Okay, you'll get your pi symbol. If it's a non-Casio calculator, it'll come up with the decimal, which is 3.1415296. Yeah, I was never very good at remembering after the first 3 digits. So pi times and then 8, and the x with the little raised 2 will give you your squared term. So pi times 8 squared. Now it will come up on some calculators as 64 pi. That's absolutely fine. Just press the button here that says S to D, turns it from standard to decimal. Okay, you get 201 point, and we're going to round it to 1 decimal place, so 201.1. And I am just going to pause for a second and just do a quick rounding there. So 201.0619. Right, just to remind you of rounding, basically what that means is because we only want 1 decimal place, I only want 1 digit after the decimal point. So I'm putting an imaginary line there. The number after that imaginary line, if it's 5 or higher, you have to round the last number up by 1, and then everything else disappears. If this number is 4 or lower, that all just disappears and you're left with what's there. Okay, so because mine's 5 or higher, I round that last number up by 1, which makes it a 1. The rest of the numbers then disappear. So that's why I got 201.1. On the next one, again, this is just a radius. So it's pi times 14 squared. So that is shift and the times 10 to the power of something button times 14 and the squared button. Again, it will give you one that's got a pi symbol on. Just press S to D and I get 615.752. So again, 1 decimal place. The 5 tells me that I have to round up, so I'm going to get 615.8 centimeters squared. Now, these two have 1 extra step involved. Because that's the diameter, because it goes all the way across my circle, I need the radius for my formula, and I know radius is halfway, so half of 22 is 11. So this one is pi times 11 squared. So pi times 11 squared is going to give us 380.132 and so on. There's my cutoff point. For a 3, I don't need to round up because it's 4 or smaller, so my answer is just 380.1 centimetres squared. Rest of the numbers just disappear. And then last one. Again, that's a diameter because it's all the way across my circle. So first thing I'm going to do is half that. Now half of 15 is 7.5. You can have decimal numbers for your radius. That's absolutely fine. So we do pi times 7.5 squared. That is going to give us 176.714. Again, there's my cutoff line. With a 1, I don't have to round up, so it's just 176.7 centimetres squared. Okay, hopefully that's made it a little bit clearer for finding area of a circle. Again, if you haven't done so yet, write in those examples, make sure that they make sense, or have another listen through, and then what you've got is 6 questions underneath for you to have a go at. And again, we're just going to label them across each row: question 1, 2, 3, 4, 5, 6. And same as all the other ones, as soon as you've done them, upload them to Show My Homework so I can have a look. If you've got any problems, feel free to write the workings for a question, send it me if you want it checked first of all, just to make sure that you're doing it right.